All right, now in this video, we're going to go through this decision problem, set some utility values, and look at how we would calculate the expected utility for both options. So the idea here is for each of these outcomes, you get the amount of money that's listed. So you can get either $10,000, $200, $1,000, or $5,000. So our first step, if we're going to set utility values, is to order these outcomes from most preferred to least preferred. And in this case, our expectation is going to be that everyone's going to have the same list, have the same ordering, with $10,000 being the most preferred, then 5,000, 1,000, and 200. Okay, then the first step, or after we've done that, our next step is to assign 1 to the most preferred outcome and 0 to the least preferred outcome. So now our task is to determine the utility values for the $5,000 and the $1,000 outcomes. All right, so I'll set this up. I'm not going to go completely through the process, but I'll set it up so that you can if you want to try it. Okay, so you have two choices. One is just to take the $5,000 or to enter a lottery where you have some chance of getting the $10,000 and some chance of just getting the $200. And so what you need to do is find the probability of winning the lottery that would make you indifferent between these two choices, between the 5,000 and the lottery between 10,000 and 200. Okay, so when you start, you could really start with any probability, but you just want to put some probability down and then think for that probability. Let's see, I'll put down 40% and 60% down here. So for this probability, when you have a 40% chance of winning the lottery, getting $10,000, or a 60% chance of losing, would you want to take the lottery, or would you just want to take the $5,000? So, I mean, whatever you might want to do there is up to you. If you took choice 1, in this case the $5,000, instead of the lottery, then you want a probability for the lottery that is higher. Or if you chose the lottery, if you take the lottery instead of choice 1, the $5,000, then you want a probability that is lower. So let's say you chose number 1 in this case, you would take the $5,000 if the probability of winning the lottery was 40%. Then you could just try something higher, 50%. Think about which you would take, 1 or 2. Or if they look equally good to you, then you could stop there. If they don't, you could go up by some smaller amount or go down, whatever it might be. But you just need to put down some probabilities, think about, with that probability of winning the lottery, which looks better, the $5,000 or the lottery itself. So at whatever point you're indifferent, so at whatever probability you are indifferent, probability up here, actually I should also be putting these down here. But whatever point you are indifferent, the probability of winning that lottery is going to be the utility value that you put here. Okay, and then you would just do the same thing for the $1,000. Okay, so this is the outcome that you're trying to, or that you are setting a utility value for. So that's going to be choice 1. And then the lottery is still going to be between the most preferred and the least preferred outcomes. Okay, so again, you can just start somewhere, some probability of winning and losing. Think about what you would do if you choose option 1 or choice 1 here. Then that means that the probability of winning the lottery needs to be higher. If you choose the lottery, then that means the probability needs to be lower until you find that point at which you are indifferent. Okay, and then same thing. At whatever probability you are indifferent, that is the probability of winning the lottery, that's going to be the utility value for that outcome. So that number will go here. Okay, we fill in the utility values for each of these outcomes. So that's going to be 1 here, 0 here, and then whatever you found for those 2 outcomes that go with bet 2. Then to calculate the expected utility for each of these options, first we multiply for bet 1, multiply the probability. And so here we have flip of a coin. So the probability of either state happening is 50%. So for bet 1, first we have 0.5 times 1 plus 0.5 times 0. That's going to be just 0.5. And then for bet 2, you would just need to supply whatever utility values you found for this outcome and this outcome. Then you could do the calculation to find the expected utility for bet 2, and following the expected utility strategy, you would pick whichever bet has the higher expected utility.